All right. Problem number 5 from section 7.5, we want to use the sum or difference formula to find the exact value of cosine of 5 pi over 12. So we know from the get-go, we're using the sum or difference formula to find this problem. And remember, our sum or difference formula for cosine would end up looking like cosine of alpha times cosine of beta, depending on what you were using, plus or minus sine of alpha times sine of beta. So there are plenty other ways that we can separate out 5 pi over 12. You can use the difference formula, you can use the sum formula, whichever one that jumps out to you first. You just want to make sure that the values that you're adding or subtracting are going to be values that you can easily find on the unit circle. So that's the main key that you really want to be doing in that case. So we can start off by getting that 5 pi over 12 is going to be the sum or difference. So the sum or diff of two angles, which remember we call alpha and beta. And these angles need to have values related angles are known. This is just to say if you're going to split up 5 pi over 12, if you're going to split up 5 pi over 12 into two different angles, these two angles should really be found on the unit circle so that you can know what they are and what their related angles are going to be. So you can split 5 pi over 12 up many ways. The one possibility, and the one that we're going to use, is going to be 5 pi over 12 is going to be equal to 2 pi over 12 plus 3 pi over 12. And 2 pi over 12 simplifies to pi over 6, and 3 pi over 12 simplifies to pi over 4. So two values that are found on the unit circle. And that's the key there. If you split up your current angle into two angles that maybe aren't on the unit circle, it's just going to be that much harder to actually solve the problem since you can't easily just refer to the unit circle to solve it. So that being said, we're going to use pi over 6 plus pi over 4. Then we get that cosine of 5 pi over 12 is going to be equal to cosine of pi over 6 plus pi over 4, which then using, in this case, our sum formula, this is going to simplify to cosine of pi over 6 times cosine of pi over 4 minus sine of pi over 6 times sine of pi over 4. So remember that our formula looks like cosine of alpha plus beta is equal to cosine of alpha times cosine of beta minus sine of alpha times sine of beta. So remember, that's what our formula is. So we're using our sum formula to rewrite this. Now all we need to do is solve for our new values. So really quickly, we can state what each one of these values are. We can state that cosine of pi over 6, this is going to end up being the square root 3 over 2. Cosine of pi over 4 is going to be equal to the square root of 2 over 2. Sine of pi over 6 is going to be equal to 1/2. And sine of pi over 4 is equal to the square root of 2 over 2. So this means that cosine of pi over 6 plus pi over 4, using our formula that we had before, is going to simplify down to square root 3 over 2 times square root 2 over 2 minus 1/2 times square root 2 over 2. Simplifying this down, square root 3 times square root of 2 is going to give us a square root of 6 over 2 times 2, which is 4. And 1 times the square root of 2 is going to be 2 divided by 2 times 2, which is 4. And lastly, we can combine these terms to end up getting the square root of 6 minus the square root of 2, all divided by 4. So that would be our answer there, but just writing this as our final answer, we get cosine of pi over 12 is going to be equal to the square root of 6 minus the square root of 2 all over 4. Another way you could rewrite it is that you could rewrite 1/4 times the square root of 6 minus the square root of 2. Either way, they're the same thing, but whichever way you prefer to write it out. So, all right, so when using sum and difference formula, it's really just being able to correctly pick out what two angles you need to be able to use, and then just using the formula. All right, so our last problem, problem number 6 from section 7.6, we want to find the exact value of the expression sine of 2 cosine inverse of 15 over 17. So kind of a bit of a mess here, but what we see is that we have sine of 2 times something else. And we know that sine of 2, say theta, we can use the double angle formula for that. So our first things first, we're going to let theta be equal to cosine inverse of 15 over 17. That means then that cosine of theta is going to be equal to 15 over 17. This also now means that sine of 2 cosine inverse of 15 over 17 is equal to sine of 2 theta. And using our double angle formula, sine of 2 theta is equal to 2 times sine of theta times cosine of theta. So this is the equation that we want to end up using. We've already found cosine of theta. We stated that since theta is equal to cosine inverse of 15 over 17, then this means that cosine theta is equal to 15 over 17. So we know what cosine of theta is. Now we need to solve for sine of theta. So solving for sine of theta, let's go ahead and use our identity that we know. Let's use the identity cosine squared theta plus sine squared theta is equal to 1 to solve for sine of theta. So if we use this to solve for sine of theta, this is going to end up giving us that sine of theta is equal to plus or minus the square root of 1 minus cosine squared of theta. And we know what cosine of theta is, so we just need to square that value. But if we notice here, we have a plus or minus. We have a plus or minus 1 minus cosine squared of theta. And this is really going to depend on where our angle is found in the quadrants. So we have that cosine of theta is equal to 15 over 17. This is a positive value of cosine. And since our range in this case of cosine has to be between 0 and pi, this means that it has to be in quadrant 1. So we're going to make a little note here. And we're going to fix it to say positive. We're going to highlight it. And we're going to say positive because cosine of theta is equal to 15 over 17, where its range, where theta's range has to be between 0 and pi. And this is because we used our formula there to take cosine of cosine inverse. So this means that our range of theta has to be between 0 and pi. And cosine is only positive in quadrant 1. So this means that sine of theta is in quadrant 1 and is positive. So all right, that's how we determine that sine of theta is equal to positive square root of 1 minus cosine squared. So continuing this on, sine of theta is equal to, now it's going to be 1 minus 15 over 17 squared. So the value of 15 over 17 squared is going to be 225 divided by 289. And if we're subtracting this from 1 here, we can rewrite 1 as 289 over 289 minus 225 over 289. And this ends up giving us 64 divided by 289. We know that the square root of 289 is 17 because we already took the square of 17 to find that value. And lastly, the square root of 64 is 8. So sine of theta is equal to 8 over 17. So let's go ahead and highlight that in blue. It's not our final answer, but it's an important one. So sine of theta is equal to 8 over 17. Now we can use our equation. So sine, our formula. So sine of 2 theta is equal to 2 times sine of theta times cosine of theta. So sine of 2 theta is equal to 2 times 8 over 17 times 15 over 17. Now we know 17 times 17 is 289. So we have 2 times something over 289. 8 times 15 is going to end up giving us 240. Sorry, that's 120. And then we multiply by 2 to get 240 over 289. I jumped the gun a little bit there. I got a little too eager. But so we see sine of 2 theta is then equal to 240 divided by 289, which means in our final answer here of sine of 2 cosine inverse of 15 over 17 is equal to 240 divided by 289. So, all right. So when finding the exact value of this expression, we really just wanted to first off recognize that we can use the double angle formula by letting theta equal cosine inverse of 15 over 17. So then we had a way to actually solve for sine of 2 theta, and then finding the values then for sine of theta and cosine of theta to solve for our final answer. So, all right, that wraps up our Chapter 7 review for Exam 2. If there are any questions at all, please don't hesitate to email me. My office hours are on Thursdays and Tuesdays from 11 to noon, or you can email me to meet another time if you would really like to go over things one-on-one and you're not able to make it to office hours. You can use the online question form, anything along those lines. Please don't hesitate to contact me in any way if you need some help studying or have anything that you want to clarify before the exam. So, all right, good luck on Exam 2, everyone, and I'll see you again in Chapter 8.